and water absorption of railways concrete sleepers containing palm oil fuel ash (POFA) as a cement replacement material. Ms. Nur Farhana, the floor is yours.
Okay. Thank you, Doctor, lecturer, and friend. But first, can I turn off the camera since my line is not stable if I open the
Yeah,
camera?
yeah, sure.
It's lagging here. Okay, let me share my slide. Okay, Assalamualaikum and good evening, everyone. Okay, my name is Nur Farhana. I'm from UTHM, and my research title is The Compressive Strength and Water Absorption of Railway Concrete Sleepers Containing Palm Oil Fuel Ash (POFA) as a cement replacement material. So basically, I will use the palm oil waste, we call it as palm oil fuel ash, to produce a railway concrete sleepers. And then I will test the performance in terms of compressive strength and also the water absorption. So first, let me introduce to you guys the railway concrete sleepers. So this is the railway concrete sleepers, the transverse structure of a railway track. So the function of the railway concrete sleepers is to distribute the load from the rail to the underlying layer. So what happened in our railway industry is, as the high-speed rail construction is increased, so the demand for the railway sleepers also increased. So according to the Space Gene in 2017, for 212-kilometer long double-track high-speed railway project, about 710,000 of concrete sleepers are needed, with a yearly demand of 10 million new sleepers. So since this railway sleeper required a high strength concrete, so we need to use a high content of cement. It's range from 300 to 700 kg per m cube. So this high cement consumption cause high CO2 emission, which can cause the global warming, and it will cause the climate change and other negative impact to the environment. Meanwhile, in our palm oil industry, in 2020, about 100 tons of palm oil fuel ash was produced and disposed to our landfill. So, however, this POFA is higher in silica content and potentially to be used as a pozzolan material. So, this is the problem statement for these researchers. So, according to the Kaiwuren, Sekochai, and Peng, in 2020, they reported that for Beijing China high-speed rail construction, the greater energy consumption was achieved by cement. So the cement represent about 42.69% of total energy, followed by the gravel and steel bar. So the POFA contain high silica content and can be used with the cement to produce a concrete. However, this POFA cannot be used directly in raw form and require further treatment such as grinding and heating to enhance its pozzolanic properties. The raw POFA that we collect directly from the factory may contain larger particle size and also higher carbon content that can slower the pozzolanic reaction during the hydration process. So the grinding process can reduce the particle size and the heating can lower the carbon content in the POFA. So the aim of my study is to study the potential use of POFA as a cement replacement material, producing sustainable railway concrete sleepers which focus on the compressive strength and also the water absorption performance. The objective of my study is to determine the compressive strength and also the water absorption of concrete containing POFA at various percentage content. So this is the pozzolanic reaction of the POFA. So the major chemical component of OPC are calcium oxide. Meanwhile, the POFA contain a large amount of silica content. So during the hydration process, the silica in POFA will react with the calcium hydroxide in the cement to produce additional CSH, calcium silicate hydrate, to improve the microstructure of the concrete and thus produce a concrete with higher compressive strength. So this is the microstructure of the concrete containing the figure A is 0% of POFA as a control without any POFA content, only plain concrete. And for the figure D is concrete sample with 30% of POFA. Both are after 28 days of curing age. So you can see at figure A for the plain concrete, the CSH gel is difficult to retrieve, but for the 30% of POFA, you can see that the CSH gel is in a large amount and the unreacted particle will act as the microfiller and fill the void, improve the microstructure of the concrete, produce a denser concrete, and hence improve the compressive strength and also the water absorption of the concrete sample. So for the general requirement of the concrete sleepers, I refer to the British Standard 13230, Part 1 general requirement for railway track, concrete sleepers and mirror. So the maximum allowable water absorption is 12% and the minimum compressive strength for the cube at 28 days is 55 megapascal. So this is my methodology. I prepared 3 mix design. The POFA as a cement replacement material at 0%, 20% and 40%. The control sample 0% of without any POFA content. And then for the POFA preparation, before I use the POFA, I dry in the oven at 105 degrees C for 24 hours. And then I sieve the POFA to remove the unwanted particle. And for the water absorption test, I refer to the British Standard 13230 and I test the water absorption by using the hydrostatic wake method. And for the compressive strength test, I use the British Standard. I refer to the British Standard 12390 and both tests are conducted at 7 and 28 days of curing age. So this is my result and analysis. So this is the result for the water absorption test versus the curing age at 7 and 28 days. So from the result, we can see that as the curing age increase, the water absorption of the concrete sample reduce. So for the POFA 20, the water absorption reduced by 22% from 7 to 28 days of curing age. And for POFA 40, the water absorption reduced by 18% from 7 to 28 days. So this indicates that the pozzolanic reaction of the sample occur. So it improves the microstructure of the sample along the curing edge and fill the void and reduce the porosity of the concrete. So although the water absorption versus the curing edge reduced, but as the percentage of POFA increase, the water absorption also increased. As you can see, for 20% of POFA, the water absorption increased about 14%. And for the POFA 40, the water absorption increased by 54%. So this may due to the use of the untreated POFA, which contain higher amount of carbon and larger particle, which tend to absorb more water. So according to the British Standard, the maximum limit for the water absorption is 12%. But since the POFA 40 have recorded a water absorption of 13%, so POFA 40 cannot be used in the railway operation. But the POFA 20 record a water absorption of 7%, so the optimum POFA content that can fulfill the water absorption requirement is 20%. Next, this is the result from the compressive strength test. So this is the compressive strength versus the curing edge. So as the curing edge increase, the compressive strength of the sample also increase. So for the POFA 20, the compressive strength increased by 35.52 megapascal from 7 days to 28 days of curing age. And for the POFA 40, the compressive strength improved by 19.28 megapascal along the curing edge. So this shows the pozzolanic reaction between the POFA and the cement along the curing edge. Okay, although the compressive strength improved along the curing edge, but as the POFA content increased, the compressive strength of the sample reduced. So as you can see, uh, utilization of 20% of POFA reduced the compressive strength by 22.72 megapascal compared to the control sample. And for the POFA 40, the compressive strength reduced by 38.96 megapascal compared to the control sample. This may due to the use of the untreated POFA, the higher amount of unburned carbon and also the larger particle of the POFA, which reduce the pozzolanic reaction of the POFA. And as you can see, all POFA concrete has compressive strength lower than 55 megapascal, so they cannot be used as a concrete sleepers. However, POFA 20 recorded a compressive strength at 35.52 megapascal, so it can be used in the slab track. Slab track, the minimum compressive strength to be used in the slab track is 27 megapascal. So POFA 20 still can be used in railway track. So as a conclusion, the water absorption increased along with POFA content indicating higher porosity. However, POFA 40 recorded the highest water absorption with more than the allowable limit of 12%. Therefore, it was not allowed to be used in the railway operation. And the compressive strength of the concrete sleepers containing POFA increased with increasing curing edge due to the enhanced pozzolanic reaction, and it produced stronger concrete. However, the POFA was not effective to improve the compressive strength. The compressive strength reduced as the POFA content increased, but the 20% of POFA can still be used as a slab track since the compressive strength is it 27 megapascal. So this is my references. Want to refer? So that's all for me. Thank you.
All right, thank you, Ms. Nur Farhana. And now I open for Q&A from the floors. Any question from our audience?
Sorry, can I ask something? Chikang here.
Yeah,
Okay,
yeah,
I would
sure.
like
Yes.
to ask that any creep and shrinkage of the okay, you use concrete as a slipper, right? They will have a creep and shrinkage. If you know, concrete will have a creep and shrinkage effect. So, uh, have you studied about this effect to the slipper? How long we need to after casting? How long we need to place there to reduce the creep and shrinkage effect to the to the to use before we can install to be a slipper.
Okay. Hello.
My question is how long we need to store it first before create
Sorry,
and
my
synchronize.
line is lagi here. Have you
Mr.
finished with your
Farhana?
question? Hello, hello. Can you hear me?
Yeah, do you hear the question?
Yeah. Okay,
Okay.
Mr. Chang Oi, thank you for this question. For my study, I only study the performance of the POFA for the compressive strength and also the water absorption performance of the POFA. That's it. Can you hear me?
Yeah, there some words we cannot hear from you, but it's okay. I guess what you are
Lagi.
saying that you only studied the compressive strength, right? So you didn't go into creep and
Yes,
shrinkage. Is that your answers?
yes.
Okay. All right. Mr. Jang,
Yeah.
is that
Your doctor.
answering your question?
Yeah, yeah. Understand.
Okay.
Thanks, thanks.
All right. Is there any question from the floors? Okay. If there is no more question, we will move on to the next presenters, which is Mr. Amrul Kaish. Do we have Mr. Amrul Kaish here?
Okay.
Yes, I'm here.
Okay. All right. So, Mr. Amrul
Assalamualaikum
Kaish,
and very good afternoon.
Waalaikumsalam. The floor is yours. You can present your papers.
Okay, okay. Let me share my slide first. Okay. Can you see my slide?
Yeah, we can.
Okay. Thank you very much for giving me the opportunity to present. Um, the paper I'm going to present is entitled Effects of Different Expansive Agent on the Properties of Expansive Cementitious Materials, authored by Abir Mahmood, ABM Mamrul Kais, which is myself, Sudarshan Raman, Dr. Masrina Zamil, and Rosjila Hamid. We are from the Department of Civil Engineering, University of Kelantan, Malaysia. Okay. So, expansive cementitious material, cementitious material, cement-based material, actually cement, the concrete, mortar, and all other types of, especially the early is cracking, and also the aesthetic appearance for the architectural concrete and all other types of concrete. So the shrinkage is considered the major reason of curling, cracking, and debonding in such materials. The exposure to unsaturated environment by a cement-based system leads to a drying shrinkage due to the water evaporation. And this causes the early age shrinkage in the concrete structure, and which also affects the properties of the concrete. So the expansive cementitious material is basically an additive that normally people use to compensate this reduce the drying shrinkage of the concrete and also avoid the formation of the cracking while enhancing the early strength and the concrete harden process. Okay, this is the principle. I don't want to go through the principle in detail. So what I just want to say is the use of expansive agent, but definitely it should be the controlled expansive agent. So it cause a little bit expansion to compensate the early age shrinkage, like the drying shrinkage because of the evaporation of the concrete. Okay. So basically in the market, we have three types of expansive agents. The first one is calcium oxide based, magnesium oxide based, and also sulfur aluminate based or type expansive agent. So calcium oxide based expansive agent contain dead burner calcium granulates, which is actually calcium oxide. And the effect of this material is when it comes to the contact with the water, it creates the calcium hydroxide, which is the portlandite crystal, and cause a little bit expansion. and based on the doses. And this one is commercially available, and also ACI 223 committee report also confirmed this type of expansive agent, which is actually type G according to ACI report. Okay, then we have contain the magnesium oxide from the clinker, which is calcined at 1450 degrees Celsius, and creating the chemically stable hydration product, which is magnesium hydroxide. And this is comparatively less water required uh, compared to calcium oxide based expensive agents. The third one and the last one is the sulfur aluminate type. This one is basically contains the calcium sulfur aluminate and also the lime, which is calcium oxide also. And this combination results in the quick development of etrinzide during the water curing. So this type of expansive agent is mixed in some Portland cement, so which are actually known as expansive cement, and also the high early strength cement. Okay, and this type of expansive cement is available in US as well, and also in the Europe. Okay, basically I'm going to discuss these four types of effect of expansive agent in the cementitious material, especially the concrete and mortar. So let's start with the strength. So the calcium oxide based EA, which is expansive agent, uh, uh, a research studied by some researcher from Italy. They identified that different amount of calcium oxide based expansive agent doesn't have that much influence on the compressive strength value. However, the increased doses of calcium oxide based EA are able to significantly increase the flexural strength of cement based composites. Cement based composite means this must be fiber reinforced. Why there is no, I mean, almost not zero, not significant influence on compressive strength, but the significant increase in flexural strength. This is because of the partial pre-stressing effect due to the expansion in the microfibers. So this is how the flexural strength of the cementitious composite increase due to the blending of expansive agents. Then magnesium oxide based EA, the expansion rate of the magnesium oxide based EA is slower actually. However, the expansion characteristics can be engineered by modifying the calcination and residence duration. And another study found that the ultimate tensile strength increase to the greater strength compared with the compressive strength. This is also due to the partial pre-stressing effect due to the expansion, pre-stressing effect of the microfibers. Okay, then the sulfur aluminate based EA, this one has not significant influence on the ultimate compressive strength, but it has significant strength on the tensile strength, and also it results a high early compressive strength if we use with a high mortar ratio in the cementitious composites. Okay, then with the flowability, most of the, like all these three types of expansive agent have a very good impact on the flowability. Good means it has impacted on the flowability. Then the result from one researcher indicated that the fluidity decreases with the addition of expansive agent, because the expansive agent causes like tries to expand and uh, causes a decrease in fluidity. And this is why the flowability, I mean the workability, is reduced significantly. So it is advised to use super plasticizer when we use this kind of, like any kind of expansive agent, to create a balance in between the flowability and also expansibility. In the expansibility, we have like overall calcium oxide based expansive agent and also the magnesium oxide based expansive agent has very high expansibility compared to the sulfoaluminate type of expansibility. So sulfoaluminate based expansive agent is actually produced the controlled expansion in the concrete structures. So most of the researcher recommends to use this type of expansive agent for the controlled expansion. And the durability, um, one study found that the reinforced concrete with steel fiber and calcium oxide based expansive agent has provided a better improvement in the permeability and the durability of the concrete. And according to GNL, the use of magnesium oxide alone had little effect on the resistance to chloride penetration of the concrete. The combination or combined effect of the magnesium oxide and chloride penetration of the concrete. And also the uses of calcium oxide based EA in hydraulic structures are less likely used in practical due to the lack of enough research. In conclusion, the factors that affect the expansibility of the different expansive agents are like doses, killing condition, and temperature. Although all types of expansive agent enhances the strength, calcium oxide based EA has the most rapid hydration process, and sulfoaluminate based EA has the most controlled expansion. So for the high early strength, we can recommend for calcium oxide based EA. However, for the control expansion, which is required actually for practical use in structure, we should go for sulfoaluminate based EA. And all types of EA reduce the flowability of the cementitious matrix, so it is advised to use the super plasticizer to compensate this the workability problem. And also the water permeability reduced due to the addition of almost all type of the EA which is reported in the literatures. These are the references you can go through for your reference. And thank you. That's all from myself.
All right. Thank you, Mr. Amrul Kaish. I open the question from the floors.
Okay.
Do we have any question? Okay, Mr. Amrul, I noticed in your slide, in your presentation, you mentioned that the combination of magnesium oxide and steel fibers
Mhm.
improve the durability, if I'm not
Okay.
mistaken.
Mhm.
Okay, did this study or maybe other studies study the this effect is because of the steel fiber, or is it has the um, contribution
Okay.
from
Okay.
the magnesium oxide? Is it the
Okay. I
contribution
understand
from
your question.
magnesium oxide, or is it because of the steel fiber, the improvement of the durability here?
Okay. Okay. Thank you for this question. Basically, the fiber, the effect of fiber is different than the effect of any other additives. Like the fiber normally do not, how to say, significantly effect on the durability. However, any additives significantly improve the durability. So what happened in this study was like magnesium oxide causes a little bit expansion that reduces the porosity of the concrete, and this is why the like durability is affected, not because of the steel fiber. But what is the effect of steel fiber here? Because of magnesium oxide is causing an expansion, and magnesium oxide normally do not cause a controlled expansion. So steel fiber is there to control the rate of the expansion. So it reduces, like because of the expansion there will be no cracking because of the steel fiber. This is what steel fiber is doing here. But magnesium oxide causes the improvement in the porosity, and that is how the chloride penetration, chloride ion penetration, and also the like any other ion penetration will be reduced. So this is my explanation. I hope
Okay,
answer to your
okay.
question.
Thank you, Mr. Amrul. Um, any other question from the
Mm,
floor?
you're most welcome.
Okay, if there is no more question, then I would like to thank Mr. Amrul guys for your presentation. Next presenter, our third presenter is Miss Habibah Afrin on the title of an overview of
Video
eco-friendly
on
alternatives as the replacement of cement in concrete. Do we have Mr. Habibah here?
Hi, I'm here.
Hi, Mr. Habibah. The floor is yours. You can proceed with your presentation.
Okay, thank you. Okay. Cerita sana sana. Hello everyone. Today I'm presenting about an overview of eco-friendly alternatives as a replacement of cement in concrete. I'm Haiba Afrin. I'm from Macquarie University, Sydney, Australia. So all of us we need to know about how is concrete. Concrete is basically a mixture of
Miss
aggregate.
Habibah, excuse me.
Yeah,
Have you opened your slides yet?
yeah. Can you see my slide?
No, we see your
Okay, sorry.
window on the files. Maybe you can share your screen instead of Windows. Yeah,
Okay.
it's okay now. Okay.
Okay, thank you. So today I'm going to present about an overview of eco-friendly alternatives as a replacement of cement in concrete. I am Haiwa Singh. I'm from Macquarie University, Sydney, Australia. So first we need to know about what is concrete and why we need to use concrete. Concrete, we all know about it's a mixture of fine aggregate cement, coarse aggregate and water. And this is one of the mostly used material in the world. Due to the global urbanization and economic development and growth of the world's population, the demand for the new buildings and infrastructure is increasing day by day. So it's about the 10 million tons of concrete produced every year, and it is the most consumed substance in the world, second only after the water. So over 70% of the world's population lives in concrete structure. And none of the material is as versatile as concrete. Its workability, strength, durability, longevity, and the fire resistance and durability makes it one of the most man-made product in the world. But it produces a huge problem with the environment, contributing 5 to 8% of total carbon dioxide emission in the world. And its high increase rate of cement production increase the demand of energy, raw material like consumption, water use, and the generation of waste as well. And you can see it's almost used at 20% of world's industrial water consumption. In the graph, you can see the production of cement is increasing day by day. And now we're trying to make concrete eco-friendly, so it doesn't consume that much raw material and it doesn't affect the environment that much. So for that, we can use industrial byproduct. So for the industrial byproduct, there is some product that already have been used, like fly ash, bottom ash, steel, the glass, plastic bag. Hello, can you see my slide?
We can see the slide, but the slide only in page 2.
Okay. Can you see my slide now? Hello?
Yeah, okay now. Can you full screen? Make it full screen.
Okay. Sorry. Uh, so for construction and demolition waste as well, we can use the wood, steel, and concrete, gypsum, and masonry, plaster, metal, and asphalt as well. And it much used to are generating in each year, and it's increasing nowadays as well. So you can see that as coal fired from station is so high rate than others as well. So it was pretty much used in the concrete. So first, I will discuss about the fly ash. It's the waste material that comes from the coal burning power plants. It's also known as the ashcrete. And in the experiment, we found that it used reduce the 20% of cement use and what 10% of water use. And it also impact on the bleeding, strength, and reduce sinkage as well. But there's another problem of using fly ash is it has a wide variety of chemical compositions from different sources. So sometimes it affect that the product quality as well. Another is bottom ash. It is a non-combustible residue of combustion in a power plant, boiler, furnace, or incineration often goes to landfill as waste. Bottom ash generated from the power plants and have become an important economic and environmental objective. Thus, recycling of alternatives to traditional landfill due to a high generation of amount and low discarding is making a very problem. But if you use it as in a concrete, it can also influence in the workability, settings time, strain, porosity, and durability. And another product is silica fume. And
Excuse me, I think it is same. The slide is not moving.
seriously, I'm moving. I can see, but I don't know. Slide number. Now, can you see my slide is moving now? Hello?
Yes, we can see the slide, but the slide is not moving. Just stay at the page 2. Previously at the page 2.
But I am moving the full slide, and but I don't know what's the problem with it.
You use two screen, isn't it?
Yeah, I'm moving it manually, but it still is not.
When you share the screen, you should choose your entire screen, not a window.
Window.
Can I help you to share the screen?
Yeah, sure. I'm just sharing, but I'm just going to from the sharing screen to the window. Then I'm just tapping because it has only in the window only.
So this is your screen now.
Okay. Hmm.
Okay. So which slide?
Yeah, I was doing. Can I take the control or no?
I can control.
Okay. I was in the silica frame.
All right.
Okay. Silica film also known as a microsilica, and it is found it can replace the concrete 7 to 12% as well, and it has a very high strength and durability properties. Can you move to the another slide? If you look at the blast furnace as well, this is another waste product that is come from the industrial byproduct, and this is often known as a Montel iron slag, and it can replace 80 to 70 to 80% of the cement, and sometimes it replaces 100% as well. And it has improved workability, higher long-term and compressive and flexure strength, and reduced permeability, improved durability and resilience. This is another one. And another waste is a ceramic waste powder. It often found in the ceramic production industry. And ceramic tiles industry produces a large amount of ceramic waste powder during the final polishing process and can cause soil, water, and air pollution. So improve the workability retention of concrete mixtures and can reduce the compressive strain development and required time. Ceramic waste powder significantly improves the durability characteristics of concrete. Can we go to the another one, please? And another domestic waste is that is glass. Implementation of waste glass powder in concrete by replacing the cement may impact the problem of dumped waste glass. So less energy cost and time are required to place and consolidate the concrete. In hardened phase, containing glass powder exhibits better strength, freeze thaw resistance, and sulfur resistance. We know about the tires. It is the most problematic waste stream, posing health and environmental concerns, acting as a breeding ground for pests and presenting a significant fire hazard. Significant reduction in compressive strength should be avoided if we could replace the crumb rubber 20% of total aggregate concrete. A reduction in flexural strength while the use of rubber fiber increases the flexural tensile strength as well. Another construction and demolition is wood ash, and utilizing of wood ash partial replacement of cement adversely it is observed an increased rate of water abortion in wood ash concrete mix. Strength properties of concrete mixture decreases the marginally with an increase in wood ash contents, but increase in age due to the pozzolaning actions. We have another recycle is a concrete. We can use as a concrete powder as well and brick powder as a replacement of cement. The major concept of the fines content of concrete in cement paste, which is possible to use as a clinker raw material because it contains a high concentration of carbon dioxide. The negative effect of concrete powder is mainly influenced by the compression strength. Only a 10% cement replacement reduced the compression strength by about 25%, and a further decrease was almost the same. So by conclusion, we can give that the potential way of achieving the sustainability can happen by replacing as much as Portland cement as possible with supplementary cementitious material, especially those are by byproducts of industrial processes such as fly ash, granulated blast furnace, ash, and silica fume. Using recycled materials to replace the natural resources. Improve concrete's mechanical and other properties, which can reduce the amount of concrete needed. Improving the durability and service life of concrete to reduce the amount of needed for their replacement. And thank you.
All right, thank you, Ms. Habibah, for your presentation. Now I open for Q&A from the floors. Do we have any question?
Okay, Assalamualaikum. Very good afternoon to Miss
Yeah,
Habibah.
salam.
Boleh saya tanya soalan? Can I ask questions?
Yeah, sure.
Sure.
Okay, alright. Miss Habibah, I just curious to know that among all the domestics or industrial waste, in your opinion, may I know which one can give you the optimum compressive strength? Have you tried to study on the different types of the test, like compressive strength or like the tensile strengths?
Not really, but I just focus on how can we use and replace use how much we can replace. I just studied on it.
Okay, in terms like just silica fume,
Yeah.
how many percentage that the maximum percentage if I want to replace the cements?
I think it will be 20%, like it's
20%.
7 to 12 to 20%.
So the range is within up to 20%.
Yeah.
Okay, all right. Okay, thank you.
Okay, do we have any more question? Ms. Habibah, I have one question. Um, how is the acceptance from the industries about this, the use of this waste into their product? Maybe the cement industries.
Yeah.
How they acceptance? Have they used any of these waste?
They pretty much use the fly ash, bottom ash, and silica fume. It has a long use. They're using almost everywhere nowadays.
Okay,
And other to this as well, glass. Even if you put a tire as well, there is some practical application in Australia.
Okay, some of the waste have been used, right? But
Yeah.
some the others waste such
It's
as
still investigations.
waste tires, the
Yeah,
ceramic is still hardly hardly we can see the
yeah,
acceptance or the
yeah,
use in the cement, right?
yeah.
So okay, thank you, Miss Habibah.
Thank you so much.
There is no more question, right? Okay, so thank you, Miss Habibah, for your presentation.
Thank you so much.
Now we'll move on to our next presenters. Uh, I would like to welcome technologist Dr. Muhammad Raizam Zamani to present the research titled Compressive and Tensile Performance of Eco-Engineered Cementitious Composite Containing Supplementary Cementitious Material as a Binder and Recycle Concrete Fine as Fine Aggregate.
Okay, thank
Please
you.
welcome, Doctor.
Okay, thank you, Dr. Can I call it you, Dr. Noridawati? Yeah? All right, okay. Thank you for that. All right, allow me a few seconds so that I can share my slide here. Okay, can you look at my slide? Boleh nampak sebenarnya? Can you
Yeah, we can.
Okay, all right, good. Okay, first of all, assalamualaikum, very good afternoon to all of you. All right, so my name is Muhammad Raizam Zamani Zain. If you can look at here, these are my team member, Dr. O and also Dr. Lee Seong Wee. I'm from the School of Civil Engineering, College of Engineering, University Technology Mara Malaysia, Shah Alam. So for today, I'm going to present my research works entitled The Performance of Eco-Engineered Cementitious Composite containing supplementary cementitious material as a binder and recycle concrete fine as a fine aggregates. So these are the outline of my presentations. I will start my presentations with the research background, okay, followed by the experimental program. Next, a detail of the test specimen and the test methods, followed by the result and discussions, and at the end on the conclusions. So first, let's look at the research background. Okay, as we know that throughout the modern era, the concrete production process has been improvised to meet the evolving industry and construction needs. And of course, there are several studies, there are multiple studies were conducted to develop a solutions for creating a more sustainable and quality ways of building so that the characteristic or the performance and durability of the buildings would improve. And the incorporations of ECC, engineered cementitious composite, into structures as a substitute for conventional concretes has become one of the studies that were conducted to resolve these concerns. So what can I say here that ECC is very ductile as opposed to the conventional concrete, which is brittle, and the ingredients of ECC are specially developed to withstand the various cracking and regulate the crack width. And growing issues of sustainability between many of the construction's material resources, as well as the public awareness of the problem, paved the way for green or eco constructions as a new or innovative methods to replace the conventional methods. So among the alternative solutions are by using the supplementary cementitious material, we call it as the SCM, a recycled concrete aggregate, RCF, and of course many other industrial waste. So the blend of SCN and RCF in a mixtures can be regarded as the eco-engineered cementitious composite. SCM, as we know, that can also improve the workability of the hardened concrete as well as its strength and durability. And as specific informations on the mechanical behaviors and the crack patterns of ECC in terms of compressive and tensile strength are minimum and the subject remain open. Therefore, a series of laboratory testing were conducted, were employed to investigate these two objectives. First, to investigate the experimentally the compressive and tensile strength of eco-ECC containing SEM as a binder and RCS as a fine aggregates. And next is to assess the failure generation mechanism which is focusing on the crack patterns of the eco-ECC. So these are the two objectives of these studies. So now let's look at the experimental program. First, let's look at the materials and mixture proportions. So the raw material used in the concrete were, as you can see here, like we have cement, we have the OPC, we have the RCF, we have water, GGBS or fly ash, we have the polypropylene fibers, and also the super plasticizer SP. The RCF employed in ECC was taken from the demolished building, which act as a fine aggregate replacement, and it was crushed and sieved to a size of below 600 micrometers. And the PP fibers used had a diameters of 19.5 meters and a length of 6 millimeter with a density of 910 kilogram per meter cube. And the water binder ratio was fixed at 0.27 in all the ECC mixtures, where a binder is a combination of cement and GGBS mixtures. So the amount of SP was kept under control at around 10 kilogram per meter cube to ensure, the purpose is to ensure the workability of the ECC mortar. So if you can look at the tables here, we have the ECC mix proportions. There are 8 numbers of specimen. So these are the proportions. And then you can look at here, there are tables on the chemical compositions of cement, GGBS, and we also have the fly ash. Okay, so OPC, if you can look at here, all right. So these are the elemental, the chemical compositions, and GGBS. We can look at here that the highest amount is on the calcareous materials, and then for the fly ash, the highest is on the siliceous materials. So these are the chemical compositions of cement, fly ash, and GGBS. So now let's look at the detail of the test specimen. Okay, there are 2 types of tests being carried out, compressive and also the direct tensile test. So under compressive load test, okay, there are 5 cylindrical ECC samples of 50 millimeters in diameters and 100 millimeter in height from each mix, along with 5 cylindrical normal concretes were cast and tested up to failure at its 7 days and 28 days of compressive strength. And during the test, ECC specimen was loaded at a constant rate of 0.5 millimeter per minute. So you can look at here. So these are the cylindrical and dot bone formworks. Okay, and then while under direct tensile test, eco ECC plate sample with cross-sectional dimensions of dot bone shape and sizes 330 times 40 times 13 millimeter were prepared, characterized, cast, and of course tested up to failures. So if you can look at the figures here, so this shows the dot bone specimen and also the experimental setup for the samples. Okay. Now come to the result and these discussions. Now let's look at the axially compressive strength of the concrete specimens. So there are 3 types of series of concrete mixture were designed and prepared, and among the 3 series, series 1 and series 2 were created to investigate the effects of the different variations of GGBS and also RCF. And then if you can look at here, there are 4 cement GGBS and cement fly ash combination are investigated. If you can look at here, look at the specimen designations, G80R0.4, I'll give you the example. So this ID indicate that the mixture contains around 80% of GGBS, and 0.4 indicate like 0.4% RCF. So these are the result of the average compressive strength at 28 days. Okay, if we can look at here, all right, the results use of, I can see, what can I say here, that the use of 70% GGBS replacement of cement with PP fiber in ECC specimen enhance the compressive strength of ECC specimen by, if you can look at here, by 1.03 and 1.16 respectively when compared to the normal concretes. So the increment could be attributed to the use of eco material like GGBS and the additions of fibers such as PP fibers, which have been shown to improve the microstructures of the concretes. And the additions of the GGBS to ECC concrete, what can I say here, that improve its mechanical properties. And then because of the higher workabilities of the GGBS, ECC mixture bond well, improving the compressive strength. And then the actions of fibers contained on the other hand, it's also contributed to the higher compressive strength obtained by the ECC mixtures. All right, so what can I say here, that this outcome may be, so these are the outcome for the under the compressive strength of the concrete specimens. So next, let's look at under the direct tensile test. So these 2 figures shows the tensile strength displacement curve between, for example, if you look at the first figures, indicates the tensile strength or displacement curve between 70% and 80% of the GGBS and fly ash replacement for 0.2% RCF. And the second figures denotes the tensile strength or displacement curve between 70 and 80% of GGBS and fly ash replacement for 0.4 RCF. So if we can look at the first figures here, it demonstrates that GGBS cements combinations, for example, G70 0.2 has the higher tensile strength values of around 5.26 MPa when compared to the fly ash cement combinations, F70 0.2 here. And then also the normal concrete, which has the lowest values of 2.47 MPa and also 3.33 MPa respectively. So these are, what can I say here, that this demonstrate that the tensile strength of the mixtures containing 0.2% RCF with 70% GGBS or cement combinations is greater than the tensile strength of the mixtures containing 70% fly ash cement combinations and also the normal concrete. And then if you can look at the second figures here, it's indicate that GGBS cement combinations for G70 0.4 seems to have the higher tensile strength values of around 8 MPa when compared to the fly ash or cement combinations, okay, and normal concretes. So this shows that the tensile strength of the mixtures containing 0.4% RCF with 70% GGBS cement combinations is significantly greater than the tensile strength of the mixture containing 70% fly ash cement combinations and also the normal concretes. Okay, now let me explain about the failure generation mechanisms of the ECC specimen. So this figure shows the ECC crack features under the direct tensile strength test. So if you can look at here, it is in the shape of dog bone. So the dog bone shaped specimen is used to regulate the locations of the cracking to ensure that the cracking occurs in the middle sections of the specimens. So some might be asking that why it has to be in the dog bone shapes. Okay, the shape is in the forms of dog bone due to the stress concentrations at the narrow necks, which yields a more accurate result. And what can I say here, that the pure tension occurs at the narrow neck area. So when the sample is loaded with a tensile force, the shoulder are wider than the gauge sections, is causing a stress concentration in the middles. So these stress concentrations increase the likelihoods of the sample rupturing away from the ends. And what we can see here, that it also indicates that cracking during the tensile strength test was mostly observed in the middles of the dog bone specimen. However, we can also observe the crack in the at 1/3 from the middle sections of the specimen. Okay, now let's look at on the last part on the conclusions. What can I say here based on the experimental studies here? The inclusions of 70% GGBS to ECC concrete specimen improve its compressive strength performance compared to the normal concretes. The greater workabilities of GGBS allow ECC mixture to bond well and thus boosting the compressive strength. And compressive tests on eco ECC specimen containing 70% and 80% fly ash reveal a significant reductions compared to normal. What can I say here? This could be due to the inclusions of RCS content in ECC sample, which might also contribute to the concrete strength degradations caused by the presence of impurities in RCF. And the tensile strength test signifies that or embodies that the eco ECC containing fly ash produce a consistent result with the values of its strength remaining in the low range, as opposed to the green ECC containing GGBS, which yield inconsistent result. So the cracking behavioral patterns has mostly been detected, as I said before, in the middles of the bone specimen during the tensile strength test, as well as some crack can also be seen about 1/3 from the middle sections of the specimens. So So with that, thank you for listening. So this is my email numbers. If you requires any informations on that, you can simply email us, the three of us, the researchers which are focusing on these materials. All right. So with that, I end my sessions. Thank you. My presentations. Thank you. All right. That was
Thank
the
you,
sessions.
Dr. Raizam Zamani. Do
Okay.
we have any question from the floor?
Sorry, doctor. Can I
Yes,
ask
yes.
something about?
Yes, yes, Mr.
Okay,
Jen.
just now you say the tensile strength, compressive strength. How about create and synchronous effect
Okay, for that,
compare with
it's
compare with the normal concrete? Okay, this is number one. Number two is cost wise. If we use this one, compare with a normal concrete, which one is more expensive? Because your one will be pushed for the future for the market, right?
yes, yes, you
So
are right.
that's why I want to know that is it cost
In
wise
terms of
which one
cost, of course, we are in the process of investigating, so there is no cost analysis performed yet for that. But
okay.
It's a good ideas. Of course, we will continue on the ideas. In terms of like creep and shrinkage too, of course, right now our final year students are in the process of investigating on the areas also. So because of the maybe because of the COVID, we still couldn't get the result on that part yet.
Understand.
Yeah,
Thanks.
yeah, yeah, yes.
Any other question?
Okay, Assalamualaikum, Dr.
Waalaikumsalam.
Raizam.
Yes, saya.
Okay, firstly, I would like to congratulate for your good research. But I have two questions. May I know what is the advantages that you are using the GGBS instead of using another pozzolanic materials? And the second one, what is the benefit of using the recycled concrete aggregate as the fine aggregate replacement? Instead of using it as the cost aggregate replacement. Okay, that's all.
Okay. In terms of like using, you're asking about GGBS and fly ash. Why I'm using that? Am I right? The first questions.
Yes, yes, yes.
Okay. So the reason I'm choosing, of course, in industrials, we have a lots of industrial or domestic waste in our countries, right? So of course, for me, the way I'm choosing GGBS because it is contain a high calcareous material. Calcium oxide is higher lah, all right, is higher compared to and then fly ash because of the it's contain a high silica contents. So I just want to look at what happened if GBS, of course, as presented by the previous previous presenters, you can replace around 70 to 80% of the GGBS because if you look at the chemical composition, it's almost like the same. The components of the calcium oxide for the to replace cement for the GGBS. Fly ash ni because yes, as I said before, is because of the it's contain high silica content on that. And then in
So,
terms of yeah.
sorry, Doctor. So if we only use the GGBS, so is it contribute to the great performance
Yes,
compared to
yes,
the
yeah,
when
yeah.
we combine?
Based on this, based on my observation, my investigations, having GGBS, of course, definitely can increase the compressive strength, okay, of the samples. Of course,
So,
for
why you combine these two
because
materials?
I also try to look at on the what happen if you have the higher silica content. Okay, that's silicous materials. For your informations, of course, right now we are trying to look at on the tannery. We call it as the tannery. You have the I think there are several terms in like binary, ternary. So we also at this currently we are at the stage of combining this. What happen if in one sample consists of both? First, for this purpose of papers presented today, I just concentrate what happened if I separate first. Okay, this sample I just add up the GGBS and another sample I just includes the silica, and then try to look at the performance uh, of having these two industrial waste.
Okay, all right.
Yeah,
For
of
the
course, for what can I suggest that by having the combination is much better.
okay, all right.
Okay, much better. Yeah, if you have, because it's like a kind of balance. If you, of course, certain part you need the calcareous material, and in one sample, sometimes you also need the silicous material. It's like a balance on certain parts. So good to have the combinations for. This is my opinions. Like good to have the combinations on that.
Because as I have read that when we are using the GGBS, normally the performance is at the later development, right?
Ah, yes,
Because
yes, correct.
so that's why
Even
I
if
need
you look, yeah, of course.
so that's why I need to know why you choose the GGBS instead using of like silica fume or another
Mm,
replacement materials.
yeah, I totally agree. But of course, sometimes we also have to look at in terms of ductility of the samples also, right?
For the next question,
Next
Doctor,
question tadi
the,
okay,
why
can
you
you
use the fine the recycled concrete aggregate as the
okay
fine particles?
recycles ni because of like uh as we know that RCF ni is like of course RCF ni okay the disadvantage of RCF ni, what can I say, because it's contribute to the like the impurity in RCF ni. So that's why sometimes you got the by this normally okay, based on the my research also, I can say that RCF content ni, when you add into the ECC sample, it contribute to the concrete strength degradations reductions lah, attribute to, because one of the reason is that because of the prevalence of the impurity in RCF. So of course all these are still at the stage of investigations, because we still think that RCF there must be a benefit of using this. We are in the process of trying to investigate further on having the RCF contents ni. Because we have to know that some RCF ni like depends where you get the recycled concrete. Okay, like maybe for us we just using the damaged building and then try to crush and sieve up to certain micrometers. But if you collect from the other sources, it might give you different result. Okay, so that kind of thing is still in the process of investigating. That's the thing that I can say.
All right, thank you, Doctor.
Oh, clear? So is it clear, Surani? Okay, anything you just like you can email us so that we can share the knowledge. No problem with that.
Okay, I will. All right, thank you.
All right, any other question? Okay, if there is no question, I would like to thanks Dr. Raizam for your presentation
Thank you.
and sharing knowledge. Now I would like to welcome our next presenter, Mr. Amirul Faiz Abdul Rahman, with the paper titled Study on Mechanical Properties of Foam Concrete Incorporating Palm Oil Fuel Ash and Mussel Shell as Partial Cement Replacement. Okay, Mr. Amirul, the floor is yours. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Firstly, can you verify, Doctor, if you hear my voice and slides?
Yeah, we can hear your voice and we can see the slide.
Full screen?
Yeah, it's full screen right now. Yeah.
Okay, let me begin. I'm Amirul Faiz Abdul Rahman from UTHM. Today I'm going to present study on foam concrete incorporating POFA and mussel shell as partial cement replacement. For introduction, the issue of construction today focusing on sustainable material. This is mainly due to the rapid development of concrete to build residential and commercial building, which use heavily on natural resources. On the other hand, waste materials were produced from agricultural activity in form of palm oil fuel ash, which is the main agricultural activity in our country. And next, the mussel shell from marine hatchery along the coastal area in peninsular Malaysia. A previous study integrated the byproduct and this residual waste into materials technology. However, there is lack study on the potential of combination of the uh, of the byproduct as cement replacement in foam concrete. Next, for the literature review, for the POFA, the structural morphology reported irregular or spherical, and the preparation process ranging from 45 micron to 150 micron. And the previous study reported POFA as cement replacement up to 30%, a decrease in compressive strength ranging from 15 to 20%. And next, for the mussel shell, the mussel shell focus in this study is green mussel shell, which is found along the coastal Pacific region, and our country on the western peninsula, mainly in Johor. The important part of the mussel shell is the middle part, which known as a prismatic layer, consists of calcium formed by the mineralization of calcium carbonate, and the thickness approximately 400 micron. Previous study used seashell waste as mortar with replacement up to 10%, improve the compressive strength up to 10%. And okay, again for this study, the material, the cement replacement materials consists of POFA and mussel shell. For this study, the POFA classified as class F and prepared achieved to 75 micron and use fixed as at 20% of cement replacement. However, the mussel shell were prepared in two different forms. One as mussel shell powder, and the other one is mussel shell ash, which is burned at 1000 degrees Celsius for 1 hour. After the mussel shell prepared, it will be used in 5% and 10% combined with the 20% of the POFA. For the methodology, design from concrete with weight density of 1,800 kg per meter cube, and the material composition consists of 1 part of cement and 2 part of fine aggregate, and the water cement ratio 0 and 0.55. For the forming agent, I'm using Sika AER 5050 with ratio 120 with a pre-forming method. Next, for the result, the workability result shows the workability test we're using J-ring test using inverted slump method, and from the result you can see that increase in cement replacement material will reduce the workability of the samples. The workability decreased due to lower specific gravity and higher porosity of POFA and MSA compared to OPC. the reduction ranging from 15% to 16%. And next, for the compressive strength, the trend shows a reduction in all mixtures. In terms of 20% POFA without addition of muscle shell, the reduction at 16%, and followed with the 20% POFA and 5% MSA, muscle shell ash. Um, when the total percentage of replacement materials up to 30%, which is 20% POFA and 10% muscle shell, the compressive strain result will further reduce. And we can see that there is differences in strength value between the muscle shell powder, which is not burnt, and the muscle shell ash. Next, for the split tensile, based on the result, it shows that the mixture 20% POFA and 5% MSA shows the closest value to the with respect to the control specimens. And then the variation, the variance of strain result was observed between two different types of muscle shell preparation, similar with the compressive strain result. And then for the modulus of elasticity, less variance in terms of MOE when combined, when the combination with POFA at 5%. And then the MOE reduced up to 18% when the cement replacement materials up to 30%. And from the result, it can be said that a combination of POFA with both MSP and MSA as cement replacement will not enhance stiffness in foam concrete specimen. For the conclusion, higher percentage of replacement material directly lower the flowability in foam concrete, and presence of POFA combined with MSA in terms of early strength shows some potential. And the mixture 20% POFA and 5% MSA has the highest potential due to 2% variation as reduction as compared to the control. As the percentage of cement replacement increases, similar trends of strength reduction observed in both split tensile and modulus of elasticity. And then the variance in strength result were observed on two different types of muscle shell. And for the recommendation, further study on combination of POFA with muscle shell recommended to investigate the long-term effect on cement replacement foam concrete. That's it for my presentation. I would like to open the question.
Okay, thank you, Mr. Amirul. Any question from the floor? Okay, Mr. Amirul,
Yes.
I'm wondering, with all of this process to produce the MSA,
Yes.
will it give an increment in terms of cost of when we want to produce cement that is containing MSA later? Let's say some industries or maybe other industries that to like to or interested in using MSA, will it give an very high increment of the cost or what? Because I can see that the process to produce this MSA is quite a lot, right?
Yes. Okay.
Yeah.
Thank you for the question, Doctor. Based on the result, the mainly the compressive strength shows not so much variation. However, the main constant is at the reason I differentiate muscle shell preparation due to the outer green layer of muscle shell, which is called periostracum, that might disturb as the impurities in uh, cement materials. Uh, Back to the question, if you ask me, will will it give a different? I think we can proceed with the muscle shell powder. However, we still need to explore on the other effect uh, from different properties and behavior of concrete before we proceed to the production. If solely on mechanical properties, I can say that the difference is not too much.
Okay. All right. Thank you. But you come up with the is it the reduction of the strength?
Yes, strength and workability as well.
So by combining POFA and MSA, you
Yeah.
observe the I can see in your slides earlier. Correct me if I'm wrong. There is a reduction of about 2%
Yes,
of
yes,
the compressive strength. So
yes,
is it
correct.
so for you that is acceptable for the reduction of the 2%?
I think that as an application in construction, it is acceptable because we can highlight the replacement material. Can We can claim that as a sustainable material, which is beneficial in certain requirement of construction.
So this decrement is it because of the POFA or is it because of the MSA or MSP? Which material that contribute to the decrement is actually?
I think it is mainly due to POFA preparation actually.
Okay. Then
Maybe if the percentage of POFA at lower percent, it will show another better potential.
okay, so there's maybe in future maybe other researchers can study if we use lower content of POFA, right?
Yes, correct. That's what I'm trying to say.
Okay. All right. Okay,
Okay.
thank you, Mr. Amirul, for your
Yeah.
presentation.
Thank you,
There's
Doctor.
no more question from the floor, right? Oh, Dr. Zainul Rizwan have a question. So please, Doctor.
Okay, Assalamualaikum and a very good afternoon. So I have one question to the presenter. So basically, for the foam concrete, because I found that your compressive strength is a little bit lower than 22 megapascal as required by the EC2 to be used as the bearing structure. Uh, so I'm wondering because you are using the water cement ratio around 0.55, right?
Yes.
So my question is it they have the potential to increase the compressive strength by controlling the water cement ratio, like slightly reduce up to 0.45, or established. Even though it may affect the workability, but I think we can use the super precisizer for the increments of the flowability. So and then my another question is, uh, any other contributions of the POFA or the MSA toward the filling mechanism on the foam concrete? Because we know the bubble inside the foam concrete is actually the mash affecting the compressive strength. So based on your observation, they have any so-called contribution from the POFA or MSA that contribute as a filler as well, not just as the reaction toward the cement the cement. So this is my question. Thank you.
Thank you, Doctor. For the first question, uh, will the compressive strength increase if water cement ratio reduced to 0.55? My answer is uh, I I don't think it will increase the strength up to 22 MPa. However, if the design weight density is changed to 2000, then we can see significant increment and reduction. If we change the density weight density lower to 1500, then it will reduce significantly. If in terms of water cement ratio, um, I don't think it will contribute that much. And next, for the question, POFA and MSA contribute to the porosity, uh, porosity in the foam concrete void. My answer is uh, because this study focus the preparation of materials up to 75 micron. So my answer, I don't think it will contribute much towards that either. However, if we change the preparation size up to lower to the 45 micron, then we can see the filling effects. That is for my answer.
Okay, thank you. Thank you.
All right. Thank you, Dr. Zaino. Do we have any other question? Okay, if there is no more question, thank you, Mr. Amirul, for your presentation. And
Thank you.
next, we have the last presenters for today's. I would like to welcome Dr. Nurhafizah binti Saleh for the research title of Comprehensive Review of 3D Concrete Printing by using ground granulated plus furnace slag. So without further ado, please welcome Dr. Nurhafizah.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih. Thank you for to the chairperson, Dr. Norita Wati. So you can see my slide.
Yes, we can see your slide.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all of you. I'm Dr. Nurhafizah binti Saleh from Faculty of Civil Engineering and Built Environment, University Tan Hussein of Malaysia. My presentation title is Comprehensive Review of 3D Concrete Printing by using granulated glass furnace sludge. Right. 3D concrete printing is a technology for producing a 3D model of an object to build of any shape or size in layer by using computer software. So we can fabricate building or construction component in completely new shape not previously possible with a traditional concrete formwork. So the advantages of 3D concrete printing. Firstly, deposit through a 3D printer, layer by layer without any formwork support and vibration process. Secondly, less labor cost in terms of manpower because of we will use a machine to uh, during the construction, and less time of work because can do construction in short time, because by using a machine we can run the machine in 24 hours. Okay, 3D concrete printing also use a material like regular concrete. It's required to use of Portland cement as well. As we know that cement manufacturing cause a gas emission production that can causes a global warming. So to reduce the application of cement, we use a waste material to replace the use of cement. So in this review, GGBS or Grand Granulated Blast Furnace Sludge was selected to replace the cements. Okay, so this is the ground granulated blast furnace slash or GGBS. This is a byproduct from the blast furnace used to make iron. So operation of temperature is about 1500 degrees. So to production in iron, there I have a waste here, select note here that produce the GGBS, ground granulated blast furnace. Okay, so why we take or we choose the GGBS as a cement replacement? Because of the similarity of chemical composition of GGBS to the cement Portland. So here is the chemical composition of GGBS. So we know that here we have a calcium oxide, silica, aluminum, and magnesium as similar to the composition of Portland cement. So okay, basically in um, normal concrete, we just consider on mechanical properties like compressive strength, flexural and tensile strength. But in 3D concrete printing, there are have four main factors that we must consider, which is pumpability, extrudability, buildability, and workability. Okay, so pumpability in concrete maintaining initial properties under pressure refer to the stability and mobility. For printing, the concrete only the soft material are preferred, where the soft material are easy to pump into the nozzle. Okay. Secondly, extrudability is stated only in the fresh properties of cement mortar to quantitatively characterize the material. Extrudability is purely based on flowability of printing concretes. And third is buildability. The buildability in printing concrete refer to the quality of material used for the printing. Buildability of a concrete is improved by increasing the layer in concrete and also by creating a cellular type of structure. So in this part, there are very important between the bounding between build layer to the layer. Okay, so and lastly is workability. And concrete workability is test of a freshly mixed concrete that decide the profile and homogeneity with which is can be combined, found, and consolidated and complete in term of while we're running the concreting. All right, so this is four of main factor that must be considered in to mix design for the 3D concrete printing. All right, so material for the 3D concrete printing, basically it seems like a mortar. We use cement, water, fine aggregate, and the additive, which is we use super plasticizer or geopolymer. Okay, so the main here is material with the high yield strength and low viscosity are preferred in concrete printing. Yield stress linked to the shape of retention and the mortar extrusion. So this is very important how to maintain the four factor letters. Okay, this is the best percentage replacement for the GGPS to replace the Portland cement, which is we have several researcher here, 1, 2, 3, 4, 5 researcher here that result between 30% to 40% of GBS replacement can give the best performance or the best the higher compressive strength uh, compared to the normal concrete or normal we just use the 100% of Portland cements. Alright, so here is compressive strength for the several researcher, last researcher. So here we can see that the combination between 4% and 60% per month will be, we get a 47.67 megapascal. Okay, and then roughly we can see here that a replacement between 30% to 40%, we can get around 26.45 megapascal to 48 megapascal strength of concrete. Okay, so this is we just replace, the researcher just replace directly without any additional of others fly ash or others. This is just a replacement between cement Portland and GGBS. Alright, so we go to the print quality. So this is a very important in 3D concrete printing. So it will be influence the quality of printability and buildability of the concretes. Okay, so there have guidelines here. Okay, so characteristics of 3D printing for the printability. First, we must ensure that the mixture is extruded through the nozzle, and good printing quality, meaning no void, no dimensional variation, and extruded material. So this 1 and 2 item must be applied or must be checked from our mix design. Okay, so if 1 or 2 do not apply, so the mix design cannot be applied to the concrete 3D printing. Okay, so and then buildability. For the buildability, 5 layer of printing material can be achieved without collapse. Okay, so we must make sure we can layer the concrete 5 layer without collapse. Okay, so here you can see here we have a 2 specimen there. So the first specimen, there have 5 layer, but the layer was collapsed. So this part cannot be, this specimen cannot be used as a 3D concrete printing. Alright. So and then for the buildability, first item is height of first layer versus height of 5 layer must be equal to 1. Okay, so this is a guideline how to measure the printability and buildability of the concrete printing, 3D concrete printing. Alright, so we go to the strength development curve with the use of different additive. Okay, so to control the workability, to control the buildability, so we need to add the additive. Okay, so this graph is show the strength development curve with the use of different additive at various stage of 3D concrete printing. Okay, so for the first part is while pumping, we use a super plasticizer, nanoclay, or thesotropy additive. Okay, and then for the second and third part, okay, this we can use the fiber accelerated nanoseed and mineral additive. Okay, so this is uh, suggestion from the branch 2019. All right, so for the conclusion, okay, even though we want to mix this make a mixed design, so the mixed design goal must be first we want to achieve the compressive maximum compressive strength, but we must consider the workability of mixed design. Okay, and then mix maximum flowability in the system. So to make sure the mixed design or the concrete is flowability is okay. So but we must also ensure that the maximum buildability upon pouring also in a good condition. So there are five most important aspects must be considered. Firstly, extrudability, flowability, buildability, compressive strength, and upon times. Okay, so for the GGPS, GGPS has a potential to replace a Portland cement with 50% until 40% replacements, and yield strength, tractability, as well as mechanic strength increase with increasing GGPS content due to angular morphology and empress face present in DGBS. So DGBS is quite good in using in 3D concrete printing. All right. So so this is several of building that have built by using the 3D concrete machine. So that's all from me. Thank you.
All right, thank you, Dr. Nohafiza, for your presentation. Now I open for Q&A from the floors. Do we have any question?
May I ask questions?
I have one question. Okay.
Sure.
Okay. Dr. Nohafiza, for the 3D concrete printing, in your opinion, may I know how do you place the reinforcement for the structural member, for example?
Okay, so for the 3D concrete printing, we don't have any reinforcement. We just for that is
So means that part have to do it manually or what?
yes, we pour the because that we must consider the three item here four item here. Functionality, extrudability, and buildability. So the very important is buildability. That means we layer by layer the concrete. We make sure that the concrete not collapse. Okay, so we must consider on that characterization.
Because what I mean, if we are going to build a house, for example, of course, you have to include the reinforcement and etc. Right? So is it have to do it manually? Yeah, I believe that one, right? You have to do it manually for that. Okay. As mentioned in the presentations, I can summarize that the success of 3D printing it depends on the properties of material. Or more specifically, I can say that the fresh properties of 3D printable material. Am I right?
Yeah.
However, I have read in certain journals, it stated that a majority of the researchers, they said that of course sand is used as aggregate but there is very limited can be found where a coarse aggregate was used. Is there any reason for that?
Okay, so for this 3D concrete printing, we just use a fine aggregate because because we have need to use the nozzle. So if we use the coarse aggregate, so it's maybe quite difficult to for the flowability of the concrete to build the structure. So in this part, we just use a fine aggregate, which is the range of size of fine aggregate is almost between 2 to 4 mm. So from the last researcher, there are used 4 mm to 5 mm size of fine aggregate only. So because we have use a nozzle, so we must make sure that the no stuck between when we want to pour the concrete.
Okay, all right. Thank you for the explanations. All right.
Any other question?
Okay.
Thank you, Dr.
I have
Raizam,
one
for the question.
Okay, I have one question.
Okay. Okay, Dr.
Okay,
Zarifah.
is it any specific mix design composition or is it same with normal Morton design 13 referring to British standard? Okay, is it any specific mix design composition?
Okay, so for the mixed design, actually there have several of because we have almost like over than 30 of researcher um, have proposed the mixed design, but so the mixed design is from calculation of DOE, okay, from the design calculation, because there are not have because in a mortar we have a 1/2, 1/2, 1/3, right? So for this, because we have also put the geopolymer and a super plasticizer. So there are have a calculation for the geopolymer and super plasticizer from the mixed design. Okay. Because of this part,
Okay,
there
thank you.
um, subjected to the like our common mortar. Okay, Dr. Suraya.
Okay, thank you.
Okay, Assalamualaikum Dr. Hafiza. Please don't angry at me because I asked the question. Okay, just a simple question. Maybe this thing is quite new to me. So maybe I know is this concrete printing has a good in terms of the durability.
Okay, so for the durability, okay. Um, because in my review is I'm considered to the replacement of cement. Okay, so for the durability is wait if I get the information for durability. Alright, so for this part, I'm not sure from the durability conditions, because from my research, I'm just only considering to the mixed design first, because this is a very because in Malaysia this is quite new, uh, because we want to produce the machine and or the pump to pour the concrete 3D, and we I'm sorry for the durability. I'm not find the detail of the durability of 3D concrete printing yet.
Okay,
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 nanti
it's
kita
okay,
nanti kita
Dr. Hafiza. Alright, right, thank you. Okay, it's okay.
alright, nanti kita bagi tahu ya.
Alright.
If kita jumpa kita bagi tahu.
Okay, VPN tepi, alright?
Alright.
Any other question? Okay, Dr. Zainul, please.
Assalamualaikum warahmatullahi wabarakatuh. I have one a question to our respective presenter, which is actually you have done like so much regarding the strength, right, for the 3D concrete printing. But I believe in the 3D concrete printing, instead of the strength and the workability, the bond between layer to layer during the printing process is also part of important to ensure the so-called integrity of the layer of the building itself. So if we include the so-called GGBS, how about the effects on the layer of the 3D concrete printing? So this is my question. Thank you.
Dr. Zainal, cannot I cannot hear your question during the apa tak dengar.
Okay.
We lost you a
Lost
little
you.
Okay.
bit.
Sorry. Okay. Okay. I believe that for the concrete 3D printing, besides that, we actually focus on the strength and the workability, because it's actually, of course, a parts of the requirement under code of practice. But how about the bond mechanism layer to layer during the printing process to ensure the uh, integrity or integrations of the layer for the building? Uh, if we added or if we associated the material such as a GGBS, how the effect to the bond mechanism or the bonded of the layer uh, of the 3D printing concrete? So this is my question.
All right. So for the thank you, Dr. Zainur. Zainur. So okay. Uh, from the we know that DGBS have a similarity of chemical composite to the Portland cement. So it will be have a similar behavior with because it's also a bonding or as a binder to the our concrete. So the behavior is seems like cement, Portland cement. And then it's good because for the buildability, we need to know that the bonding between layer to layer must be in a good bonding because there have not have any reinforcement to build the construction to build the structure. So we need to the good bonding between layer by layer. So I think for the GGBS will also have a give same bonding characteristic with seems like the concrete cements, Portland cement, because there have also reported by the several by the researcher, last researcher, which is uh, GGB have a high yield strength and high in a bonding of between concrete to concrete or bonding between layer to layer. So hopefully after this is the review. So after this, we're going to make a experimental for this concrete printing, and I will uh, test for the bonding characterization between layer to layer for the 3D concrete printings. Inshallah.
Okay. Thank you for the answers, Dr. Nafiza. Do we have any other question? Okay, so no more question. Um,
Excuse me, please. I just want to add something like
yeah, yeah.
to Dr. Nur Hafiza. Like you mentioned that in the mixed design, we use super plasticizer and geopolymer. I think the information is a bit is not correct, I think, because geopolymer is a completely different thing than the usual concrete. It's not an admixture. Geopolymer is a binder, same like cement. So yeah, and that's the comment, not the question.
Okay, yes, that Amirul Haish. Good. Okay, so there is for the geopolymer is also for the there have two categories of geopolymer, which is it will influence the workability also and the bonding of between or a binder as in a concrete 3D. Okay, because in 3D concrete printing, we need to consider to use the geopolymer and the superplast laser also. All right, thank you, the Amirul Haish.
Okay, come.
Okay. All right. Any other question or feedback? Okay. If no more question, thank you, Dr. Nafiza, for your presentation. And that is the end of our uh, session here. But before we end this session, I would like to announce that we have one paper that is awarded for Best Paper Award, which is the paper with the title of Compressive and Tensile Performance of Eco-Engineering Engineered Cementitious Composite Containing Supplementary Cementitious Material as a binder and recycle concrete fine as fine aggregate. This is by technologist Dr. Muhammad Raizam Zamani. Mak Zain from UITM Shah Alam.
Congratulations, Dr. Raizam.
Congrats, Dr. Raizam, for the Best
Thank
Paper
you.
Award. Um, and before that, I would like to ask for all audience and presenter to turn on your camera for a photo taking session. Can everyone turn on your camera? Okay, ada technical team ke yang akan ambilkan gambar ke macam mana?
Syarul
Siapa Syarul
Okay.
Okay.
Ready 1, 2, 3. Sekali lagi. Sekejap Okay, 1, 2, 3. Okay dah.
Okay. Thank you.
Right, thank you.
Cheryl. Maybe last announcement. I would also like to announce that the certificate and receipt for your fees will be emailed to all presenters by tomorrow, provided that you have supplied the proof of payment either to our treasury or upload in the COMSE system. Okay, if all clears, we can proceed with the receipt, then the email should follow after that. So that's all for today. Thank you everyone for your contribution, for your participation, and for your interest to our conference. I hope we can see you again for the next GCOMSE 2023. I hope. Okay. So with that, that is the end of our session. Goodbye and thanks everyone. Assalamualaikum.
Assalamualaikum. Thanks
Salam,
everyone.
thank you semua.
Bye-bye.
Bye bye.
Thank you everyone.
Thank you.
Bye bye.